Hi, my name is Tim Crowley. The purpose of this video is to provide some additional material to supplement my resume and to highlight some great experiences I have as I look back on my career. The first thing I'd like to show you is a test project that I was involved in very early in my career, known as LEAP, or Lightweight Exoatmospheric Projectile. This was an early missile defense program where we were developing kill vehicles which slam into an enemy missile to destroy it by the kinetic energy of the impact. And the way we would test this is in a hangar up at Edwards Air Force Base, where we would do what's called a hover test. And this picture here shows a hover test, and it's a great way to test a kill vehicle, to test the integration of propulsion with a guidance, navigation, and control system. It was a great experience for an early career engineer, and I look back on that with a great pride to have been involved in that. It was cutting edge stuff when we did it, and it's still a really neat thing. The next project I'd like to share with you is kind of a next step in the evolution of kill vehicle and missile defense, and it was called Flight Test Vehicle 2. And this was where we were actually integrating a kill vehicle into a Navy Standard missile, which is a ship-based missile that's today used in the Aegis cruisers for missile defense. And this particular test was the first time that a kill vehicle had been integrated into a Navy Standard missile. And here you see a picture of our kill vehicle, and incidentally this kill vehicle was not a full-up one. It was kind of a mock-up kill vehicle. It had a real inertial measurement unit. It had inert propulsion, but the purpose of this test was to demonstrate that we could integrate a kill vehicle into the Standard missile and fly it. Next picture shows a kill vehicle with a larger, wider angle view showing the missile assembly, the nose cone, an ejection mechanism that was used to eject the kill vehicle, and then some test equipment in the foreground. And then this next photo is a photo from the actual flight test where we had ejected the kill vehicle. We had a camera mounted behind it so we could watch the kill vehicle ejection. And then further in the background you can see the Standard missile nose cone, which of course was ejected before the kill vehicle. That was a real exciting to be involved in that, a real space flight test. That was a great experience that I look back on with fond memories. Next project I'd like to share with you, I kind of switched gears and went to a single stage to orbit program called X-33 that you may recall from the late 1990s. The idea was to develop a vehicle which would be a single stage to orbit, to take payload to orbit. And the winner of that competition was Lockheed Martin. I was working at Rocketdyne at the time, and Lockheed Martin, their X-33 flight vehicle, which was a lifting body vehicle, they chose an aerospace engine for the propulsion, which is a engine architecture that features an open nozzle that allows it to optimize the thrust plume throughout the launch trajectory for optimal performance. This picture here shows a isometric view of that XRS 2200 engine, and it was pretty innovative. It had 10 thrust chambers, 5 on each side of the 2 ramps. It was really an exciting thing to be involved in. Incidentally, it had turbo machinery that was borrowed, that was left over from the Apollo program, second stage and third stage engines. And that was the core power pack for this engine. Next photo shows an actual engine that we produced. And then, unfortunately, X-33 never flew. They could never get the vehicle to work. I believe they couldn't get the fuel tanks to hold the liquid hydrogen. They were composite tanks and couldn't get it to work, and I think they never could close a technical case of getting a payload to orbit with a single stage. But at the time, it was exciting to be involved in. We had real hardware. We were, full bore going for it, and just didn't pan out. But it was exciting nonetheless. Next project I'd like to share with you is from roughly a decade ago. It was a DARPA project called Orbital Express, and the purpose of this program was to demonstrate a robotic technology to repair and service satellites on orbit as opposed to replacing a whole satellite. It was a cost-saving measure. This Orbital Express had a robotic arm, the same guys who make the arm for the shuttle, or who made the arm for the shuttle, and they had various subsystems for fluid transfer and changing out ORUs. It was a demonstration program, and the part I was involved in was a subsystem called the ARCS, or Autonomous Rendezvous and Capture Subsystem. We had a couple visible sensors, infrared sensor, and a laser rangefinder, and this allowed autonomous docking and rendezvous and docking with a target satellite. And in the Orbital Express, we flew a surrogate satellite that we were going to perform the servicing on or demonstrate it, and that was connected, of course, initially to the Orbital Express. Then the surrogate satellite separated and backed off, and then we went back and rendezvoused with it and then performed or demonstrated these servicing operations. That was really another exciting project to be involved in, and a completely different from what I had done previously, doing autonomous rendezvous and capture. Anyhow, that in summary is some of the highlights of my career, give you a little bit more insight about me, and hey, thanks for your attention.